Hello and good day. This is Jan Karremans. I head up sales in cybertech, but I still think I have sufficient technical background to take you along on an interesting journey on securing Postgres with streaming replication. It is one of the hidden in plain sight cool features of Postgres that might just help you save the day. So let's start with the presentation. As I said, I have been in sales at cybertech for quite a few years. Even longer, I've been active in databases, um, longer than I care to remember, almost 30 years. And the interesting bit is that the last 6 years, I've also been able to combine um, Postgres as a community governed open source technology together with Kubernetes, which is also an open source community governed project, which, the combination of both is super, super interesting. Um, I work for Cybertech. We are a pure play Postgres company. This is a lot of marketing, blah blah. But I think it's interesting just to have a quick peek on pure open source Postgres, working with Postgres, and why that is so very important. If you want to know more, please go to our website and you will find a lot more. Um, Core thing is that Cybertech is focused on Postgres. It's in the heart of what we do. And we want to contribute to the community. We want to contribute to the project and we want to help businesses succeed with Postgres. One of the things in that is basically streaming replication. I think it is one of the everybody knows it. Most everybody is using it, but not everybody has really thought a lot about it. And I think it's a very interesting piece of technology that I want to highlight really in this presentation. What is streaming replication? Why does it even matter to you, and why should you care? You know, the world runs on data. Data is we've heard it all the new gold. So that means that every organization, every entity, everything that you do is really built up and around data. And if you start missing pieces of this data, if you are starting to miss, just a change or a bit of data, we all get into this very scary situation that even though you trust your system, and if you ask something of the system, you expect to get a full and correct answer back. If there is actually these kind of things happening, you just might be in for a disaster, right? Um, Data in databases, I feel, lives in transactions. If it's just the pure stored data, you wouldn't have to put it in a database. You could just write it on a piece of paper, right? So change is the default. The value of the data is in the fact that it can actually revolve and stick to the changing situation in the world. What we want to do is secure these changes, make sure that we don't miss those specs of changes. We want to be able to replay these changes inside the actual system you're working on or in an external system. And you want to do this, I've called it dead or alive, or dead and alive, actually. You want to record changes and have them be stored as a fixed something, but you also want to do this alive. You want this to live on in another system. So these things help ensure that the data, the things that you're working through are captured and made sure. Um, Streaming replication inside Postgres is basically built by Simon Riggs. Everybody knows and respects Simon, and unfortunately, he's no longer with us. And Simon told me, please be aware that protocol foundations that are necessary for streaming replication were actually created by Hans-Jürgen Schönig from Cybertech. So actually, streaming replication is built on the technologies that these both gentlemen have created for Postgres, for which I am incredibly grateful, obviously, because otherwise we wouldn't have streaming replication. These changes live in the transaction log that gets created on the primary system. A transaction comes in, it gets processed in a transaction engine, it ends up in the the wall log or the write head log, and then from there, persists in the data files, it persists in the transaction log, etc. These changes are also available at an IP endpoint, the blue antenna in this graph, and can be picked up by a replica database, which is a secondary database, a complete independent Postgres cluster living somewhere else that actually listens to these transactions, receives the transactions, writes it to its own wall log, and persists it in its own data file. So in this setup, you actually have changes that are happening on primary getting replicated to the replica database, as the name fittingly says, and gets persisted there, right? Um, Characteristics for streaming replication, it's binary compatible. That might sound trivial, but there are a lot of use cases that actually require a standby or a replica database, a copy of that database that you're using for backup or disaster recovery purposes, to be binary compatible with the primary. So it's one-on-one the exact same system. If you look at other technologies that you might have looked at or heard of, like logical replication. In that case, the databases aren't binary compatible anymore. So those are things to take into consideration. Streaming replication works out of the box. I vividly remember my very first Postgres cluster that I set up, and thinking, hey, it's so easy to add a replica database to a primary. Well, yes, it is. It is rock solid, super secure. This technology has been around for a very, very long time. Very many organizations use it. And if you're not using it today, there is no license restrictions to add a second node to your Postgres cluster. So please do that. Set up streaming replication, go play with it. There is, a world of interesting things to gain here. So, that was the basis of what is actually streaming replication. So if we now take this and start translating to, what does this look like in reality? It starts with, this very single lonely Postgres cluster. It lives, in, God forbid, but you might even have, transaction logging not enabled, or having it disabled, which makes the database very fast, admittedly, but please don't let anything happen to it, because if you're not even logging your transactions in a transaction log, if your database crashes, it won't start up anymore because it has no ability to come back to a new safe state, right? So the first thing you want to do is actually enable transaction logging. But then still, there is this one single Postgres cluster, and that really makes not very much sense um, from a reliability perspective. You're not using that fantastic technology called streaming replication that is actually available for you to play with. So one of the first things you want to do is either start shipping WOL files. These transactions are written in so-called WOL files, write ahead log files, and you can actually copy those and make your own sort of running backup of it. Cooler even would be to add to the next level, which is going to an entity where you stream transactions to another location. So that builds sort of a backup that is continuously being added on as transactions happen in the primary database. That at least gives you the ability to do point in time recovery in a much finer grained fashion than you would do with WOL file copying, because if the WOL file isn't full and you're not switching to the next one, it's not copied to the safe location. So if you have a disaster happening exactly in that middle point, you're missing transactions, and you don't want that because Core lives on data and you don't want to miss a spec. So we go to a world where we have a primary database and we have a replica database. Transactions written in the primary are then streamed to the replica database, are applied in that replica database, much as we saw in the little graph earlier on, right? So that at least ensures that my second database is in the same situation as my first database. If something happens with my primary node and it disappears, I can simply evolve that replica database, promote it, if you like, to be a primary database. One of the things here that is super interesting is that you can do this asynchronously and synchronously. Asynchronously would mean if something happens on the primary, it is copied to the replica, and at some point it will be taken up by the replica, but you don't really care. The focus is on the primary, just keeping working on the primary, and these transactions will be streamed to the replica anyway. The other mode would be synchronously, and synchronously would say, if something happens on the primary, I want to have confirmation that it also happened on the replica, so that if something happens with the primary, I am absolutely sure that that also happened on the replica, so I don't miss data. That sounds very cool, but there are dangers, and I am biased in this case, so you have to do your own thinking work. My personal bias is I would not really want to use synchronous replication too much. That has to do with the fact that if you write something to a primary and you're going to wait, remote write on or remote apply on your replica to say, I have either, consumed the change or actually, as in remote apply, completely made sure that it's also persisted on my replica database. There is time involved. There is time involved to get the transaction to the other side. There is time involved to get it processed locally, to get it um, made consistent and made durable. And all of the time that replica is working, your primary is waiting. If there is one thing which is key in the world of database transactions, it's the triple P, right? PPP, performance, performance, performance. What are you going to have if you're waiting? You're not going to have performance. My feeling is that the Postgres streaming replication fact, the systems these days are so incredibly reliable that you can rely on asynchronous replication to be sufficient. But again, this is my bias. Do your own research because it's very important. So what you would get is then go to a primary and replicas where one set sits in one data center, the other one sits in the other data center. A good idea could be to have the primary and the replica which sit in the primary data center to have a synchronous connection, and then stream the other transactions asynchronously to the other data center. Why? Because the latency in that first data center where the two nodes are sitting very closely together will probably be very low, and you will probably get away with the performance impact of that synchronous replication. But the transactions that have to go all the way to the other side of the city or the country or the continent or whatever, you don't really care. Those transactions will eventually end up in that other data center and get persisted there. That's not as important. Another way you could do, and this is what we call the maximum availability architecture, is start playing with synchronous and asynchronous, in this case with synchronous replication, but there are some tunable things in there as well. So what you could do is, I am building a primary and I'm streaming um, synchronously to replica locally, and I'm going to send the transactions to another data center, a second or a third data center. And what I'm going to say is, I have three synchronous standbys, S1, S2, and S3, but I'm going to only wait for the first two. Probably the one which is sitting next to the primary will be the first one, so you got one check. And then you're going to wait for the first one of the two remote ones to say, I have committed the transaction on my side. We'll also send that back, and you don't care about the third one. The third one will still transact, and both the two replicas on the remote side will also stay, in sync, but you don't care about waiting for the synchronicity of it, right? So this could be something where you could start playing. One of the things we're looking for in the government software, the governance software around it, is that you can also start playing with how many synchronous standbys automatically, and reconfiguring actually going from synchronous standby to asynchronous replication, just for playing to get maximum availability um, established in favor of the synchronicity. This is a concept that is derived from other technologies and might actually, in some cases, make sense. Another cool feature that we can also play with is cascading replicas. So in this case, we have a primary and a replica, a synchronous replica. Both the synchronous replicas, so the primary and the first synchronous replica, have asynchronous replicas in that same data center, but that replica is also streaming replications to the other side, or the transactions to the other side, where you have another mechanism with the primary and a standby happening as well. So this is basically an endless cascading game that you can play with, where you can actually start building up how you how you build out your replication sets. There are a lot of more tools around streaming replication. I've just highlighted three, which I think are super important. HA proxy for ensuring that if you have a primary and a replica, you can actually play with that, where your transactions will end up. Patroni as a tool for governing primary, replica, failover, switchover. So that's basically a tool that sits on top of streaming replication and automates streaming replication. And finally, one that I wanted to highlight is PG Bouncer, which is a connection pooler. It isn't necessarily tightly linked to streaming replication, but it allows you to play with, if I've got 1,000 systems coming into this one database, actually build a queue and play with that a little bit. So that would be, streaming replication and how you could work with that. Then, what does it actually mean? And I think we talked about this already a little bit, right? Streaming replication is a toolbox, the toolbox that gives you the creativity to build exactly that form of high availability, that form of disaster resilience in Postgres that you would need. The technology is rock solid, super secure. With it, you can build, your own data protection mechanism that, holds no boundaries. With it, what we saw, you can have you can secure a single Postgres cluster to building really globally dispersed data protection strategies. This is one of the coolest things about streaming replication for me. It's so easy, it's so incredibly logical, but still so super powerful that you can do so many different things with it. Um, and just talking about Postgres itself a little bit more, and this is derived from streaming replication in some shape or form. Ans Lasma, colleague of mine here at Cybertech, has put some things together that I wanted to quote because I just thought it was amazing. Postgres ecosystem, it will solve anything, right? It has been around for over 25, almost 30 years, and everybody has been working with it. Recently, I stumbled over a list of database systems derived from Postgres. That list alone is arm's length, right? So anything that you would need Postgres to do, somebody else will have thought about it. Somebody else will have built something for it. So, if you would do an internet search, Postgres probably has a solution for that. And it doesn't really matter. You will still get the job done in that sense, right? Um, So basically, from there, just use Postgres. You don't have to look at other systems and use it until it no longer works, right? Then you get into optimizing Postgres, finding that one extension that might just do what you need it to do, right? Um, and it will just do the job. Only then you will get to a point where you say, "Hmm, perhaps my workload is so super special that I need, a specialized, special purpose tool to do what I need it to do," right? The chance that you will get to that, and if you're lucky, you will never get to that step number four, right? Because if it goes from graph, document database, AI these days, you know, think about any crazy things, Postgres will have the solution. Postgres will just do it, right? So to summarize that, Postgres is the best because it's good enough for the task you didn't know you had. And I thought that was a very powerful statement. And basically, this puts me at the end of this incredibly quick talk here. There is dozens of things more to talk about streaming replication. I just wanted to highlight these few things. Cybertech is not alone in the world. We're part of the Open Source Business Alliance. We're part of PG for Business. Um, Proud contributor to Postgres and founding member of the Open Alliance for Postgres Education. Coming to that, as you watch this presentation, the Open Alliance will have been is live, and if you want to find out more, you go to oipg-edu.org and just find more or scan the QR code here. Final reminder: PGD Austria live again, September 4th, 2025. Schloss Schönbrunn in Vienna. Tickets are live. Call for papers is open. Call for sponsors is open. Very well recommended and very much endorsed.